Ever wondered if scattered data points hide a pattern? That's where linear regression helps. Let's take a simple example. House sizes and their prices. We have data showing different sized houses and what they sold for. The points are scattered, but there seems to be a trend. Larger houses generally cost more. How do we find the relationship between house size and price? We could try drawing a line through all the points, but as you can see, no single straight line can pass through every point perfectly. Linear regression finds the line of best fit, the straight line that best summarizes the relationship. It minimizes the total distance, residuals, from all points. The line doesn't have to be perfect, just the closest fit.
You might remember the basic line equation from school, y equals mx plus b. But in statistics, we use a more descriptive version. Let's break this down piece by piece. Y is what we want to predict. In our case, the house price, x, is what we use to make that prediction, the house size. Beta 0 is our starting point, where the line begins on the y-axis. Think of it as the base price before we consider the size. Beta 1 is crucial. It tells us how much the price changes for each unit increase in size. If beta 1 is large, price increases rapidly with size. Finally, epsilon represents the error, the part our line couldn't explain. No model is perfect, and epsilon captures what we missed. So how does the computer find the best values for beta 0 and beta 1? It uses a method called ordinary least squares, which works by adjusting the line to minimize the sum of all these squared errors. Watch what happens as we try different lines. The algorithm keeps testing until it finds the combination that gives us the smallest total error. This optimal line is our linear regression model. The algorithm starts with a random guess and then systematically improves it. With each iteration, the total error decreases as the line gets closer to the optimal position. Now for the exciting part, using our trained model. Let's say we have a new house that's 7 units in size. We can use our regression line to predict its price. We find where 7 on the x-axis meets our line, then follow across to the y-axis to get our predicted price. The model estimates this house would cost about 6.2 units. Linear regression isn't just for house prices. Businesses use it to predict sales based on advertising spend. Educators use it to forecast student performance. Healthcare professionals use it for risk assessment. The applications are endless. What makes linear regression so powerful is its simplicity and interpretability. You can clearly see how changes in your input variable affect your output.